Hello everyone, welcome to the session. Today we are going to talk about locators. Do you know what is a document object model or DOM structure? Is it inside a HTML or is it constructed when you launch a web page? Is it suggested to use Playwright's built-in locators or the general locators like CSS? Which is the fastest? Which is the reliable locator? This session is going to cover all those information. Right now in the market, there are various tools that can generate the locators for you. But while you are learning, do not use any of those tools. Once you get a hold of the locators, once you understand how to write effective locators, then you can make use of those tools. When you are implementing the automation, you can use those tools to improve the speed of implementation. But while you are learning, I would suggest you to manually write those XPaths or CSS or various other locators. And the agenda for today is going to be understanding the DOM structure, how it is related to the locators, and what are different element nodes on a web page, what are the Playwright's built-in locators, and what is the advantage of using those built-in locators, what is the fastest locator or what is the reliable locator. If you consider any web page, it will have three key components: the HTML, CSS, and the JavaScript. Let us consider this as an example. Just for the sake of easy understanding, I have represented the HTML content and CSS and JavaScript on the right hand side. So the first, you can see the HTML which has the structure of the web page. So whatever you are seeing on the left hand side, you can see the HTML is consisting of the whole structure of the web page. And if you look at the CSS content, it has the styling information of the card. Now I'm going to make a change to the CSS, to the background of the card and the color of the heading. So you can see the background has changed. And if you look at the JavaScript, it controls the behavior of the button. Similarly, on any web page, these three things work together to display the content and to control the styling of the elements and to control the behavior of the elements when you click on an element or when you interact with an element. And coming back to the HTML, it looks something similar to this. So how can a programming language like JavaScript can understand this HTML? Because HTML is not a programming language, it's a markup language. When this HTML is launched inside a browser, the browser will construct a tree type structure which is similar to this, which is called as a document object model, where each node is considered as an object and the whole HTML is considered as a document. JavaScript or the tools like Playwright cannot interact with the HTML directly. Instead, they use the DOM interface provided by the browser to perform actions based on the live state of the page. What is the live state? Let's say you launched a web page. Let's call it as the original state or the default state. And then you start interacting with the web page. Starting from the home screen, you click on a product and you enter into the add to cart screen. And if you want to interact with a web element on the add to cart screen, you are interacting with the live state. You are interacting with a screen which is different from the originally launched web screen. This is where the DOM will help you to interact with the live state of the page. And also I mentioned on the HTML, every node is treated as an object. What are these nodes? So there are three primary nodes on a HTML. Element nodes, which are nothing but the HTML tags, the div elements, the paragraph elements, headings, the text nodes. Any element that contains text inside the tags is treated as a text node. And the attribute nodes. These are nothing but the properties of the element nodes, like ID, class, name, that you notice on the element nodes. And the modern web technologies like React, Angular, they generate some of these attributes during the runtime, which means some of these attributes may not exist in the initial HTML, but they'll be created when you interact with the page. So now what are the locators? So when you want to interact with an element on the web page, like entering data into a text box, clicking on a button, selecting a radio button, we are indirectly interacting with the element nodes which has some attribute nodes. So we need an identifier for the automation script to find these elements and interact with these elements, which are nothing but our locators. And there are various locators that you can make use of, like ID, name, XPath, CSS. And in addition to these, Playwright also offers a set of inbuilt locators. When we already have elements like ID, name, XPath, CSS, etc., why is Playwright offering these built-in locators? These built-in locators rely on user accessibility properties or semantic elements, which means the visible information or the element properties which conveys the information. For example, the label or the placeholder. These are some of the properties that we manually use to locate an element. So the built-in locators also use the same mechanism to identify the elements. These built-in locators are more resilient in nature, which means they are less prone to the failures. Why? Because they are relying on the user accessible properties. If you take CSS or XPath, which are relying on the underlying DOM structure, and if a HTML tag or the position changes, then the locator might fail to find an element. Whereas in the built-in locators does not rely on the DOM structure and has auto waiting capabilities like to be visible, to be enabled. And coming to the speed of finding an element, in general, the all the playwrights locators or the built-in locators have auto waiting capability. So usually they are all quick in nature, but relatively the CSS is faster because it maps directly to the native browser APIs. Now we can consider a problem statement and start creating the script using the built-in locators. I'm going to use this e-commerce website for our demo session today. You can see the home screen has few products and we have 0 items in the cart, and you can see it is not logged in. Let us click on the first product and then we will click on this add to cart button. You can see the cart has 1 item now. Now let us click on the my cart button and we can see the item that we have added. Let's click on this checkout button, and on this screen let's verify if the total amount is the same as what we are expecting. Now let's go back to the VS Code and start writing the script from the scratch. For our today's session, let us create a new folder called session 4, within which we can create a new file for our today's session. Now right click on the folder you created and click new file, and let us name it as built-in locators.spec.ts, which is our mandatory suffix for any of the scripts you are creating. And what will be the first step? Importing the required functions. The first one is test function to be able to define your test case, comma expect to be able to add any assertions to your test case. And as per syntax, we have to wrap them inside the curly brace, whether you write one test function or multiple test functions. From, we have to specify the package which contains these functions that we are importing, which is nothing but playwright/test. Now the next step is defining the test method. It starts with the keyword test, and the first argument is going to be the name of the test case or the title of the test case, which is verify the add to cart functionality. As we are going to verify the item is added to the cart successfully and the total amount value is matching with what is expected. And the second argument is going to be a arrow function, as every function starts and ends with a curly brace. Let's specify that, and we have to define this function as a async to be able to use the await keyword and handle all the asynchronous actions. And we have to specify the page fixture inside the arrow function so that it gives us access to the browser's page object. Now the base test method is completed. Now we have to launch the URL. Navigate to the application URL, and we can use the page fixture to launch the URL, but every browser interaction must start with the keyword called await. So await page dot go to and paste the application URL as an argument. Now let's go back to the home screen and inspect the first product. You can press F12 or right click on the product and click inspect. You can see the developer console is launched, and this is the HTML node for the product we are interested in. And for this element I want to use get by role. But do you see any role attribute here? No. As it is an image, you can see the src as one of the attribute, and there is a class which is not unique in nature, so we cannot use class to identify this element because there will be more than one match. Then how do we identify the element using get by role? To understand that, we need to look at two different examples here. The first one is implicit accessibility attribute. Why are we calling it accessibility attribute? Because all the playwrights built in locators are interacting with the accessibility attributes or semantic elements, the elements which convey the information. If you look at the submit button in the first example, where the element tag name is button, and if you look at the playwrights command, page.getByRole, and the first argument is also button. So for some of the elements, you can specify the tag name as its role name, which means it is implicit accessibility attribute because the role of the attribute is already specified in the tag name. In some cases, the HTML tag name may not explicitly specify what type of element it is. If you look at input, so the input does not indicate if it's a text box or something else, because the input element is a generic HTML element that supports multiple UI elements such as checkboxes, radio buttons as well. So we cannot use input as the role name. So in this case, in the second example, if you look at the email, which is a text box by looking at the UI, but the tag name is input here. So if you look at the playwrights command in the second example, it is page.getByRole. The first argument is text box. And how do we differentiate between what is implicit and what is explicit? And how can we identify the right role name that need to be used? There are two ways to do that. If you look at this sheet, so we have a standard list of element nodes and their corresponding role names. So we can use this or to identify the right role name. And you can see the input element has multiple variations of roles based on the type of element. It can be a checkbox or a radio button or a text box. Also the drop downs may have select element. The role is combo box in that case. And you can make a note of how a list is represented and a table headers are represented in the roles. This is a web standard provided by W3C to manage such accessibility properties like role. And we have another way of finding this role information on the browser itself. Let's see how it is. And you can right click on the element which you are interested to find out the role name. And then you can see the accessibility tab on the developer console, which will have the accessibility information associated with that element, like the role and the name of the element, and also the alt text if there is anything. So you can use the role and the name information from here to enter in your playwrights command. And similarly, you can inspect any element and find its role information. Now let's go back to the VS Code and start writing the command, which is page.getByRole, and the first argument is role, which is image in our case. Do you see image here? Based on the syntax, it is img. Let's write it here. If you look at the syntax, so the second argument is a name attribute. So what is the name of this image we have? Let me copy it from the accessibility properties. It's gray jacket. Let's paste it here. And the operation we are performing is click. And since it is a browser interaction, so we have to specify await keyword as well. And if you notice, we specified the name property in a key and value pair inside a curly braces, because When you specify a property inside a curly braces, the JavaScript syntax consider that as an object. So it is a JavaScript syntax. So to specify the property one or multiple. And you can ask me, why do we have to follow JavaScript syntax while we are creating the script in TypeScript? That is because TypeScript is a superset of JavaScript. All the JavaScript concepts, syntax are still valid inside TypeScript as well. Now moving on to our next action, clicking on the add to cart button. Let's inspect the add to cart button. And if you pay attention to the accessibility properties, it indicates the role is button and the name is add to cart. Let's try to use it to click on this one. And it's going to be page dot get by role. And the first argument is the role name, which is button in this case. And the second argument is inside the curly braces, name colon. Let me copy it from the application. It's add to cart. And the type of operation is going to be click. And it's a browser interaction. So let me specify the await keyword as well. If you want the script to compare irrespective of the uppercase or lowercase, so we have to make a change to the name value here. So you have to specify it as a regular expression. You can remove the single quotes and you have to wrap the text inside a slash, forward slash. Let me mention it before and after, and then followed by a flag called I. It indicates that the script is performing a case insensitive comparison. And now we can comment the first part where we are making the direct comparison. We can make use of the second statement where we are performing the case insensitive comparison. Let me also make it lowercase so that we can see how it's functioning. Now as a next step, I want to click on this my cart link. Let us inspect that. This is a anchor tag element, which means a link with a text my cart. This time let us use page.getByText instead of the role. So it's page.getByText. And what is the text content? My cart. Let us make use of the regular expression again. So instead of the quotes, just specify the forward slash followed by I, which is the flag for case insensitive, and the operation is dot click. And since it is a browser interaction, let me add the await keyword. Let's try running the script once. And the command is npx playwright test -- headed, as we want to see the execution. So we do not want headless mode. You can see the browser is launched and it has failed. Why? Let's see what happened. So it failed to click the my cart button. Let me download and open this error file. This has all the information related to the failure, and you can notice there are two resolved elements for the my cart locator. So we have to update the locator or select one of these elements to click on it. So I want to fix this by specifying the index of the element. So before click, I would mention first dot click. So it is going to interact with the first occurrence. Let me run it again. Visually we won't be able to notice if it is successful or not, but we can see, yeah, it's successful now. And I will discuss all the possible options in our upcoming sessions. Now the next step is clicking on the checkout button. Let me inspect, and by looking at the accessibility attributes, we can make use of the role and name, which is button as the role and name is checkout. Await page dot get by role. The first argument is the role name, which is button, and the second argument is the name inside the curly brace. Let's mention the regular expression again with the forward slash followed by I dot click, and this will take us to the cart screen. Now on this screen, if the cost value is matching our expectation, so if I inspect this, you can see it is a header tag, so the role needs to be heading and the value is $55, and this time it is going to be a validation step. So it starts with expect, await, expect of, and what is the argument, the value that you are expecting, which is coming from page dot get by role. What is the role? Heading. And the second argument is name. I just want to compare the amount value, which is 55, and the condition we want to verify is to be visible. Now let's try to run the script once. npx playwright test headed. You can see the validation is successful. Let me copy the report command to view the test results. This concludes our session for today related to the built-in locators, and the next session is going to be around the other locators such as CSS, XPath, etc.